So the basic concept we're trying to convey is that we might encounter a cell like this somewhere, in the work field. So basically, we have a system where parts are entering our system, and we're retrieving those parts, through our PLC or through some type of programming. But it's an automated retrieval system. The second thing that's happening is the part is coming over to a machining station, where an operator will pick the part up, clamp it in place, and it'll actually get machined. So it's similar to some type of automotive industry where parts are coming into the system, they're getting clamped, and then from there it's going and being stored until it's being used later on in another process. So we're showing that initial step where a raw material is coming in, the initial machining is being done, and then it's stored, and then it can be retrieved later on. I'm making the slider case system, right? So it's a little weird. I've got a basic design of what's going to be done on SolidWorks, and so basically this part right here, that's the tabletop that slides across. And initially what we had was just two robo cylinders with a motor and a rotation, the gripper rotation. But we discussed it with a few teachers, and they said that there's a lot of flaws in the design. So what we had to do was we had to add stabilization systems horizontally and vertically to support the robo cylinders, because they're not strong enough to be able to do what we needed to do. And we also added a gear system inside for the motor, so that it gets better torque and it can actually turn the gripper without much effort. And basically that's mine, and we're in the process of making it right now, and we'll hopefully by next week it should be completed, the stabilization system, and then we're going to start on the gripper design. And we're just waiting for some parts to come in for the gears and stuff, just to get it started.
The safety aspect of here, that includes mechanical, electrical, all that good stuff. After is what it does, it picks up the component from the bending machine, and it brings it over on the sliding table to what they designed, brings it over to the clamping mechanism, and that's when at this point the operator is really needed, right? What he does, the operator, if this machine is currently in motion, this green piece lights up, right? Telling the machine that this is a new part. As it is being drilled, the blue one lights up, and during all this time, the operator can go in there, he can position it correctly just in case if it doesn't, if it's not drilling properly, or the component itself is moved too much to the right, too much to the left. He goes in there and he puts the component in properly, and afterwards, when he's satisfied with the right position, he closes the gate, and this little dial over here, it clamps the part over to the mechanism, and it unclamps it and clamps it. So as you clamp it, the actual mechanism closes, and the process is turned on by the blue light. As it turns on, the drill comes down. We don't have a drill, right? We have the actual component, but this thing itself is just an overview of how much space we can work into. So the drill comes down, drills the actual holes into the component. We're using a little block of wood, or we'll see in case what you have. It drills actual holes, and after when it's done, it retracts, and that's when the blue light turns off, and operator can go in there and place it on top of back to the retrieving. He takes it back to the actual storage here. The whole thing over here is designed for the operator to work in a safe environment. As you have the door interlocks, limit switches over here just in case, if it doesn't mount properly, all that stuff.
Okay, so suspension unit here, it's made up of 12 dispenser motors. Okay, these motors fire the actual dispenser unit, which brings the block of wood onto this conveyor. Okay, this conveyor motor is really simple. It's a 2-wire motor, DC, 24 volts. Okay, the process is going to work like this. You have a programmer programs, the PLC, so that an operator can just click a button and says, okay, I want a block of wood from this motor. Okay, when that happens, this motor will activate, bring the block of wood here, and then this motor, okay, will activate this conveyor. The block of wood will be placed here. We plan to have a sensor to activate, well, basically to signal that the block of wood is in there, so that the robo cylinder, which the rest of them we're talking about, can come and grab it with the gripper.
Well, I just basically helped everyone with the machining, plate here, and wiring, and everything else. for the HMI though, it's next to the screen here, so it's not going to be just pictures or anything. It's just going to be basically like C++.
We actually took those wires, put them in this terminal block, and then we attached them to this multi-conductor cable, and we brought it inside of it. Oh, it's right here. Sorry. It's inside here. It comes down. Yeah. It's gonna come down onto this block right here. So everything's all in one place. Instead of having the whole bunch of wires coming down to our block, we have the multi-wire. It gets plugged in here, and everything gets wired to our outputs. These are our relay outputs for the our HMI PLC.
Oh, okay.
Together, all in one, the Q block. And then from here, we took these wires back to here, and then they will be through ribbon cable right here.
Oh man, you got the graveyard there.
Yeah. Through ribbon cable, they will be brought back. So instead of having a whole bunch of wire, now all we do, we just plug these in, bring them up to the PLC, easy to wire. Yeah.